So we are using ethanol and about 10 milliliters of the ethanol for recrystallization. With this ethanol, I can wash the spatula to transfer everything that is left on the spatula. And if you have a lot of crystals left on the filter paper, you can rinse the filter paper into the, this is like to make sure you transfer everything from the filter paper. Sometimes you can just soak the filter paper with ethanol, try to recover. And today, because our concern is not percent recovery, we really don't have to be concerned about how much we are getting. So this sample now is going to be heated in hot water. We will heat in hot water bath. So I can hold it with the clamp or a test tube holder or anything that can hold it securely in hot water. And for a few minutes, for the temperature of the ethanol to get closer to boiling point of the ethanol, and hope that all crystals would dissolve. But I have to tell you something, DNPs, these crystals are not very soluble in ethanol. So after like 5 minutes heating, or when the solution starts boiling or it reaches to boiling point of ethanol, if there is some crystals, don't worry, those are the DNP crystals. And if there was any impurity, it would have dissolved in ethanol. So if there are some crystals, continue heating for just the 5 minutes, remove it, just the 5 minutes, correction, just the 5 minutes, or if you see the ethanol is boiling. And remove it, cool it down, you get your additional crystals back. Whatever was dissolved, it will come back. If there was like a soluble impurities, it will not come back, and we are not worried about soluble impurities. We want them to stay in the solution, so we can filter it. So you transfer all your sample, add 10 milliliters of ethanol, and heat up for 5 minutes. We are recording. It's okay, like us, that we pause recording, we continue recording, and then we will remove it after 5 minutes. Not every crystal dissolved, but I already said that is all right. Because we have some crystals already, it's going to place in ice bath for crystallization to complete. You can two approach. You can leave it on the your workstation to cool down to room temperature. That would give us like larger crystals. But since you already have some crystals in, I kind of rushed and I placed it in the ice bath. The proper technique would be to leave it to go to the room temperature and cold enough to touch, then you place in the ice bath for complete precipitation. So as I have always said, for recrystallization, I am using this like rule of 5. I'm icing the sample for 5 minutes, and that's for complete precipitation. Then I do vacuum filtration for 5 minutes to make sure that all the solvent is removed. Then I transfer to oven and I place in the oven for 5 minutes. That the oven that is set at a temperature higher than the temperature of the solvent, but lower than the temperature of the melting point of our product. And after the sample is completely dry, we take out, we measure the melting point. And what do we do with this melting point? The lab manual explains that clearly as well, but you are going to use the melting point along with the melting point of the original unknown, which in this case we know is ketone for unknown B, and we identify and come up with the name of this ketone. Okay. If the purpose of the experiment is to determine the percent yield, we have to wait for much longer. But since I have some crystals and I'm just concerned about getting a few crystals to measure the melting point, I stop the crystallization at this point. I'm going to do vacuum filtration. To begin with, I turn on the vacuum and pour the sample. Because we want to make sure the crystals get in there, and mix and pour, mix and pour, mix and pour to make sure all the crystals are transferred. Now, cold ethanol, because ethanol is the crystallization solvent, cold ethanol is used for washing, but I use it for two purposes: to transfer leftover of the crystals and for washing. So we need to do one more proper washing, and that is closing the vacuum, adding the washing solvent, then turn on the vacuum. Okay. Now I can wait long enough for all the ethanol or the solvent to be vacuumed and drained out, and I have more than enough crystals to measure the melting point for this sample. I will run this for like 5 minutes. I might pause the video and come back, and after that, we place in the oven. Okay, after the 5 minutes, we will remove the funnel, the butyl funnel, and close the vacuum, and just slide the paper over a watch glass and make sure that the crystals with the filter paper, or in this case, just the crystals, because we're concerned about the crystals only, are transferred to watch glass, and we place these crystals in the oven. Okay. I have the sample that is dry already. I place the open end of capillary. I tap a few times, get the sample in, and pass it through the glass tube. Now, I check the table, and a majority of the derivatives, they have over 150 melting point. So if it's over 150 melting point, the setting can be higher this time. I'm going to put between 6 and 7 to be safe. I place my sample in and wait until this is melted. I'm going to actually pause and come back to this. Okay, the sample is starting to melt, and the temperature is at 234. I'm going to take a picture, and it's melted already. 236. So I will add these pictures for you, turning off. And you are going to identify one of these unknown based on your observation. That's the end of this experiment. The key is that you come up with name of the unknown, and you have to be able to kind of defend your case and say, based on all physical properties, solubility, and other extra information, we conclude that this is my compound. Thank you.